is designed to introduce lipoproteins to A-level candidates in an exciting format. The video was filmed in West Dorset and is brought to you by Professor Peter Pulleridge, who is a leading expert in the structure and function of lipoproteins.
Hello, I'm Professor Peter Pulleridge, and I'm going to talk to you about one of the most fascinating areas of biological science, lipoproteins. I have studied lipoproteins for 47 years now, and they're still as exciting as the first day I met them. Lipids present in the diet must be absorbed and transported in the blood. This represents the classic problem of oil and water not mixing well, as the lipids are very hydrophobic and the plasma is an aqueous. The problem is solved by associating very insoluble lipids with more polar ones like cholesterol and phospholipids, and adding proteins to form lipoprotein complexes, which are hydrophilic. The protein portions of lipoproteins, called apoproteins, constitute some 60% of some complexes and 1% of others. The apoproteins are non-covalently bound to the surface of lipoproteins. They act as binding sites and enzyme cofactors in the metabolism of various particles.
Lipoproteins are classified by the size and type and ratio of proteins and fats they contain. This also determines their size and density. The large lipoprotein complexes are chylomicrons and very low density lipoproteins, VLDL. They consist largely of a lipid core of non-polar triacylglycerol and cholesterol esters, surrounded by a more polar phospholipid cholesterol and apoproteins. The most predominant lipids in high-density lipoprotein, HDL, and low-density lipoproteins, LDL, are phospholipid cholesterol, respectively. The process of lipoprotein metabolism is superbly demonstrated by this new video. Follow me. As can be seen from that video, the mechanisms that lipoproteins are involved in are very exciting and stimulating. Oh yes.
Chylomicrons are formed in the intestine from absorbed lipids and apoproteins generated by the intestinal epithelium. They are large particles, 80 to 500 nanometers, that are less dense than water. Chylomicrons are formed in the intestinal epithelial cells and then pass out of the cells into the tissue fluid. From there they are collected into the central lacteals of the intestinal villi. The lymphatic system carries these large lipoproteins to the general circulation. Chylomicrons transport dietary fats, from the intestine to adipose tissue and the liver. majority of VLDL are derived from the liver and represent the transport mechanisms for triacylglycerol from the liver to other tissues. The mechanism of manufacture and release is remarkably similar to the particulate secretion of chylomicrons in the intestine. Except for the mammary gland, the liver and intestine are the only tissues that secrete particulate lipid. Particulate lipid is unable to pass through capillary walls without prior hydrolysis, and therefore is relegated to the lymphatic system. VLDL deliver endogenously synthesized fats to adipose tissue. Both chylomicrons and VDL, 30 to 100 nanometers particles, are metabolized and cleared from the blood rapidly. Adipose tissue, heart and muscle do most of the metabolism. This is accomplished via the action of the enzyme lipoprotein ligase, lipase, present in blood vessels and tissues. The lipoprotein complex becomes bound to the walls of blood vessels where the enzyme hydrolyzes triacylglycerol to free fatty acids and glycerol. Some of the free fatty acids are released into the blood, but most are transported in the tissues. The resulting chylomicron remnants are much smaller and are enriched in cholesterol and cholesterol esters. These remnants are taken up by the liver by a receptor-mediated mechanism. The liver and intestine synthesize and secrete the smallest, 7.5 to 10 nanometers, most soluble and protein-rich lipoproteins, HDL, but the intestinal sources lack a protein that is added later from liver sources. HDL contains cholesterol esters at its core, surrounded by phospholipids and protein.
Of course, plasma HDL concentrations are inversely related to the incidence of coronary artery disease. HDL is thought to act as a cholesterol scavenger, carrying surplus cholesterol from the tissues to the liver. HDL removes the cholesterol from spherical tissues and prevents lipid accumulation in arterial walls. Some metabolic disorders involve elevations in plasma lipoproteins. Certain diseases, such as cirrhosis and hyperthyroidism, produce high serum cholesterol levels. Possible clinical manifestations of high plasma lipoproteins are atherosclerosis and pancreatitis. I hope you've enjoyed this fascinating journey through lipoproteins. I have. So, from myself and Bertie, goodbye.
Production was brought to you by Atco Ben Tim Productions, all rights reserved, 1972. Camera work by
Tariq Ben Mohammed Ramadan Mohammed Ali Abdul Razak Al-Ghedi.
Produced and directed by Tim Heel,
And Matthew Atkinson.
also starring Bertie Lizard as himself. Any resemblance to characters, either living or otherwise, is purely intentional. The living or otherwise is purely intentional.